Welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this problem without a calculator. So we have 2023 factorial over 2021 factorial plus 2022 factorial. Now the factorial of a number is that number, so let's say a factorial. This would be a times a minus 1 times a minus 2 all the way to 1 until a reaches 1, right? So the factorial of 2023 would be 2023 times 2022 times 2021 until we get to 1. So we have 2023 factorial over 2021 factorial plus 2022 factorial. Well, we could actually write 2023 factorial as 2021 factorial times 2022 times 2023. Because 2021 factorial is the same thing as 2023 factorial, besides it is missing the times 2022 and times 2023. And I'm going to divide this by 2021 factorial times 1 plus 2022. All I did was I factored out 2021 from 2021 plus 2022 factorial. And 2022 factorial divided by 2021 factorial is just 2022. So now, as you can see, we could cancel these out because these two are multiplying. And 1 plus 2022, well, this is equal to 2023, right? So then the 2023s, these two cancel out as well. And all we would have left is 2022 over 1. And this is equal to 2022. So this is our answer. Welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential problem without a calculator. So we have 5 to the power of 5 times 4 to the power of 7. So what I'm first going to do is I'm going to rewrite this as 5 to the power of 5 times 4 to the power of 5 plus 2. Now, an important property of logarithms is that if we have a to the power of m plus n, this is the same thing as a to the power of m times a to the power of n. So if we have 4 to the power of 5 plus 2, this is the same thing as 4 to the power of 5 times 4 to the power of 2. Because 5 in this case is m and 2 is n. And we're still multiplying this with 5 to the power of 5. Now, another property of logarithms is that if we have a to the power of n times b to the power of n, this is equal to a times b in parentheses to the power of n. So right here we have 5 to the power of 5 times 4 to the power of 5, and 5 in this case is n, and 5 and 4 are a and b respectively. So this can be converted to 5 times 4 to the power of 5 times 4 squared. Now 5 times 4 is 20. So now we have 20 to the power of 5 times 4 squared. Well, 4 is the same thing as 2 to the power of 2. So we have 2 to the power of 2 to the power of 2. So now we have 20 to the power of 5 times 2 to the power of 2 to the power of 2. Now, if we have something, now this is actually another exponential property, but if we have a to the power of m to the power of n, so if we have a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 2 to the power of 2, this is the same thing as 2 to the power of 4, because we're simply multiplying these two. And I'm going to rewrite 20 as 10 times 2. So we have 10 times 2 to the power of 5 times 2 to the power of 4. So now, remember, we're going to use this property, a to the power of n times b to the power of n equals a times b to the power of n, but we're simply reversing it. So we're going to convert this form back to this form. So a times b to the power of n, so 10 times 2 to the power of 5, this is the same thing as 10 to the power of 5 times 2 to the power of 5. And we're still multiplying this with 4. And now remember this property, when we're multiplying two exponents, we add our exponents. So 2 to the power of 5 times 2 to the power of 4, this is 2 to the power of 5 plus 2 to the power of 5 plus 4, which is 2 to the power of 9 times 10 to the power of 5. Now, 2 to the power of 9 is equal to 512. And 10 to the power of 5 is simply, when we're multiplying something with 10 to a specific power, we're simply adding the exponent amount of zeros to that number. So we're going to add 5 zeros to 512. So we have 1, 2, 3, 4, 5. So this here is our answer to this problem.